Hi everybody, I'm just going to walk you through some notes about atoms that we will just kind of solidify the learning that we did last class. And I know I'm not here, but these are the notes that we completed with the other class that I wanted to make sure that you had as well. The benefit of a video is that you can pause as you need to make sure you get everything written down. As I ask a question, it will also be helpful for you to pause, think about it, and write it down on your own, and then double check if you got it right. That will just help solidify it in your brain for you to think about it on your own. So to start, you can see that there is a box from the periodic table, and there are a handful of different numbers and symbols on it. And so when we take a look at any element on the periodic table, there is going to be this top number. And I want you to try to think about what that top number stands for. And it is called the atomic number. And then the information it provides is that it tells us the number of protons in that atom. Yesterday or last class, you should have learned that as you change the number of protons, you also change what element it is. And so that is going to be a key number for you to think about. The other thing I want you to pay attention to is this number. And hopefully you remember that this is the atomic mass. And the atomic mass is made up of the same, or your equation would be the number of protons plus neutrons. There's an E in there, N-E-U-T-R-O-N-S. And so that is your equation. We learned about that last class. And then lastly, you have the element symbol. And just a thing to note is that the first letter is always going to be capitalized. And so that's important when we get into different chemical combinations and molecules. For example, NaCl is basic table salt. You know that that's two different elements that are combined together because you see two capital letters. Same with if you had, let's see, CO is not a element that is CO, like cobalt. It's actually a capital C and a capital O, which tells you it is a carbon and an oxygen. And so that's just something to keep in mind that will be helpful down the road. So once you have all of these symbols, it can tell you a lot about how the atom is created. And so when we think about protons, for a definition of protons is it is a positive charge particle. Okay, and you find that from the atomic number. Okay, a neutron is a neutrally charged, so I'm going to use the symbol for a 0. If that doesn't make sense to you, you can say no charge. And then electrons, you should recall, are negatively charged. And then it's important to keep in mind where these are all located. And so the protons and neutrons are both located in the nucleus. And the electrons are floating around in an electron shell. So it is not in the nucleus. So those should all be review from last class that you kind of explored. We just want to make sure that these notes are super solid so that it is a point of reference for you to come back to. When we look at this helium atom, if we assume that it is a neutral charge, we can figure out how many protons, neutrons, and electrons are in this atom just by looking at its kind of box in the periodic table. And so I want you to pause, see if you can figure out how many protons, neutrons, and electrons they are. Write that down and then restart the video and check your answers. All right, hopefully you paused. We can find the number of protons by looking at the atomic number. And so the atomic number in this case is 2, so there are 2 protons. Then if you look at the atomic mass, it's 4.003. For our purposes, we're gonna round, and so 4 minus 2, because there's 2 protons, equal 2. So there are 2 neutrons. And then we wanna make sure that it is a neutral atom. So it is not charged, meaning it's not positive, it's not negative. And that means that both the protons and the electrons have to equal out. And so there are also 2 electrons. Okay, moving on to really thinking about drawing an atom. I want you to pause the video and after I'm done explaining this, and I want you to think about how could you draw a neutrally charged atom. So you know how many protons, neutrons, and electrons are in there. I want you to draw what that would look like based on what you learned last class. Okay, hopefully you drew something that looked similar to this. So if I'm gonna be using red for protons, I might have a positive symbol and a positive symbol, and then my neutrons are just gonna be empty. And then I am going to float my electrons on the electron shell around the atom. Okay, so I have my 2 neutrons, 2 protons, and 2 electrons. The electrons are on the outside floating around. Now I want you to think about how can you make a helium ion? And we're looking for a negative ion and a positive ion. And to be more specific than just negative or positive, the official name for a negatively charged ion would be an anion. And a helium or a positive ion would be a cation. And I am somebody who kind of likes like little tricks to help you remember different things. I always remember the difference because cats have paws. So cations are positive ions, if that helps you. So I want you to pause and think. Remember that if you're going to change the charge of an atom, for it to stay helium, you can't change the number of protons. So the protons have to stay the same. How would you make it negatively charged? Draw it out. And how would you make it positively charged? Draw that out and then come back and check your answers. Okay, so you should have positive, positive, neutron, 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 proton, proton. Okay, the nucleus of the atom does not change. The change is going to occur when you have your electrons, because that is what is going to change during bonding to make things charged or uncharged. So to make it more negative, you need more electrons than protons. So I'm gonna put an electron here and an electron here. And then if you remember from the lab activity, hopefully you caught this, that only 2 can go in that inner shell. And so we have to make another circle and we would add an electron here. For helium, with a cation, we have, again, the same nucleus, but instead we want more positive charges than negative, and so instead of having 2 electrons, we're going to take 1 away, and we're only going to have 1. And that allows us to have a positive helium ion. Hopefully this was good review. When you are done with this, I want you to get up, grab a glue stick from the counter by where the maps are. You're gonna glue these notes into your science notebook for page number 1. Have a good rest of class.